Back in the days of Objective-C, you had to manually put the retain and release calls whenever they were needed. You had to add the calls in the right places and the right order, and then you had to balance them. So for each retain, you've got exactly one release. When a stripped-down version of ARC was introduced in macOS Snow Leopard, it solved the hardest problem with those calls. Suddenly, you no longer had to think about them at all. So, when you enable ARC in Objective-C, and in Swift it's always enabled, you no longer need to write any retain release calls. In result, your codebase becomes smaller and easier to maintain, and you can focus on the parts that are really important, instead of dealing with the boilerplate. But if you had a look at the compiled app, you'd notice those calls have made their way back into the program. That's because the most important step of memory management takes place even before any memory is allocated. At compilation time, the ARC compiler analyzes the code and actually inserts the missing retain and release calls. These instructions are responsible for managing the object's reference count. And when the app is running, the ARC runtime systems observes the execution and reacts to changes in reference counts. That means it's known when objects should be removed from memory even before the app launches. The runtime then basically just monitors the reference counts, and when one of them reaches 0, the system frees up the memory. Automatic reference counting solves the majority of memory management problems. And unlike garbage collection, ARC has very little performance impact at runtime. I guess that's why it was adopted on iOS, back when devices weren't as powerful as they are today.